Today we are going to explore the forgotten secrets of medieval builders, construction techniques that defied time and that, surprisingly, surpass many of the modern methods we use today. Before continuing with the video, remember to subscribe to the channel for more documentary narratives like this one. Somewhere in England, a cathedral rises silently against the grey sky. Its stone walls have witnessed centuries of history, wars, plagues, revolutions, and extreme climate changes. It remains there, unshakable, while buildings constructed only 50 years ago around it already show cracks, infiltrations, and signs of advanced deterioration. This scene, which repeats itself in countless European cities, raises a question that few dare to ask. Did medieval builders know something that we have forgotten? The answer, as we will discover throughout this investigation, is not only affirmative but deeply disturbing. Construction techniques developed more than 700 years ago were abandoned, prohibited by modern building codes, or simply forgotten in the name of progress. What the master stonemasons of the Middle Ages understood about materials, structures, and durability was replaced by faster and cheaper methods, but not always better ones. This is a journey through time, an investigation that will take us from the workshops of medieval artisans to the laboratories of the Massachusetts Institute of Technology, and what we discover along the way may completely change the way we think about construction, durability, and the true meaning of progress. The story begins with something seemingly simple: mortar, that pasty mixture that joins stones and bricks into solid walls. Modern builders use Portland cement, a material invented in the 19th century that revolutionized civil construction. It hardens in a matter of hours, allowing works to advance quickly. It seems like a natural evolution, an unquestionable technological advance. But scientists at MIT made a discovery in 2023 that put this certainty in check. When medieval masons prepared their lime mortar, they added pieces of unburnt limestone to the mixture. For centuries, historians and engineers assumed this was simply sloppiness, a flaw in the grinding process that ancient artisans did not bother to correct. The truth, however, was exactly the opposite. Those apparently careless pieces were an ingeniously designed self-repair system. When cracks inevitably form in the walls over the years, rainwater penetrates through these fissures and dissolves the limestone fragments buried in the mortar. The calcium-rich liquid fills the crack and hardens again. The wall literally heals itself without the need for maintenance teams, scaffolding, or expensive repairs. Modern Portland cement is too rigid to allow this process. It cracks more easily than the material it replaced, and once cracked, remains cracked until someone pays to fix it. York Cathedral in England still uses traditional lime mortar in its repairs. The reason is simple and pragmatic. Every time restorers tried to use modern cement on the 800-year-old structures, they caused damage to the original stones. The ancient recipe works better on the ancient building. But there is a problem that sealed the fate of this superior technique. Lime mortar takes weeks to cure completely. Portland cement hardens in hours. When money talks, patience goes out the door. And so, building codes in most countries began to require Portland cement for structural work. The material that self-heals became technically illegal. Humanity banned the superior product because it was slower. This pattern of abandoning superior medieval methods in favor of faster modern alternatives appears repeatedly when we examine the history of construction. And the next example involves something even more surprising: wooden pegs. Oak pins might sound like ancient history, a museum curiosity with no relevance to the contemporary world. But these small wooden cylinders possess a characteristic that no metal screw can match. They get stronger when it rains. Metal screws and nails rust over time. As rust expands, it cracks the surrounding wood, gradually weakening the entire structure. An oak pin, on the other hand, swells when it absorbs moisture, tightening its connection instead of loosening it. Medieval carpenters were not simply hammering pins into holes. They used a technique called draw boring. The artisans drilled the holes through the two pieces of wood to be connected slightly misaligned with each other. When the pin was inserted through both holes, it physically pulled the timbers against each other, creating a permanent connection without the need for glue, nails, or metal brackets. Barns with wooden structures built in the 14th century still remain solid today. Meanwhile, metal-bolted structures from the 50s are crumbling and require constant repairs. This is a performance difference of 600 years that should make any modern engineer stop and reflect. The masters of the medieval guilds knew exactly what they were doing. They did not prohibit metal fasteners through laws, but through knowledge passed down from generation to generation. Iron destroys wood from the inside out. A single cathedral roof could contain 50,000 wooden pins, each hand-carved to match the specific orientation of the wood grains. This level of craftsmanship took years to master. But modern building codes require metal connectors in every structural joint. The method that lasted for centuries is now technically illegal in practically all developed countries. The next discovery involves something no one would expect to find inside a castle wall. Medieval builders had a characteristic that left Victorian architects absolutely perplexed. They were brilliantly, unabashedly economical. Approach any castle or cathedral wall, and you will see what appears to be solid cut stone. Perfectly fitted limestone blocks, an impressive demonstration of skill and resources. But open one of those walls, and you will find something completely different. Total chaos. Irregular stones, broken tiles, construction rubble, basically any trash that was available at the construction site. The Tower of London, those intimidating ramparts that protected kings and prisoners for almost 1,000 years, are composed mainly of raw chalk and flint covered by a thin layer of limestone. It is the architectural equivalent of wearing a designer suit over pajamas. The appearance suggests one thing, the reality is completely different. For a long time, modern engineers assumed this was simply a way to cut costs that, by some stroke of luck, did not result in disaster. Then they decided to test these walls. The results were surprising. Rubble cores perform superiorly during earthquakes compared to uniform, solid walls. The explanation is elegantly simple. All those irregular shapes create interlocking friction inside the wall. When the ground shakes, the pieces of rubble shift slightly, absorb the energy of the tremor, and then settle again. Solid walls cannot do this. They resist, until they crack catastrophically. Medieval builders saved 60% on materials while accidentally creating earthquake-resistant structures. Or was it really accidental? These were the same professionals who built cathedrals that are still standing 900 years later. The technique was abandoned because it requires masons who understand which combinations of rubble work. Too many round stones and the wall collapses. Wrong proportion between large and small pieces, and the structure becomes unstable. It is like a recipe that only master chefs can execute. Modern codes require consistent materials throughout the entire wall. This part of the investigation enters genuinely strange and admittedly a bit unpleasant territory. Medieval builders added oxblood to their mortar deliberately, not as part of some obscure ritual, although that assumption is understandable, but because it worked. Blood creates tiny air bubbles throughout the mixture. Why does this matter? When water freezes inside the mortar, it expands. Cracks form. Walls collapse. But those microscopic air pockets give the ice space to expand without destroying everything around it. The technique is called air entrainment nowadays, a fancy term. We pay good money for synthetic chemicals that do exactly what pig blood did for free 700 years ago. And it gets even more interesting. Urine was also on the list of ingredients. The ammonia in urine accelerates the curing process and increases the initial strength of the mortar. Records from German guilds of the medieval period officially specify 1 bucket of pig blood per barrel of lime. These professionals were not improvising. The chemistry is solid. Laboratory tests confirm that blood proteins work exactly like modern synthetic air entrainment additives. Science validates what seemed like madness. Modern sanitary regulations prohibit biological materials in construction products, which makes sense from a hygiene standpoint. Interestingly, Chinese builders discovered the same principle using glutinous rice instead of blood. Different culture, same chemistry, without the unpleasant factor. The next technique sounds like every building inspector's nightmare: intentionally crooked construction. Medieval builders did not trust perfection. It sounds contradictory, doesn't it? We spend millions on laser measuring equipment to ensure that walls are perfectly straight. Medieval masons did exactly the opposite, on purpose. They built walls slightly curved inward from the start. The reason? They knew that every building settles outward over time. Stone compresses, foundations shift, wood shrinks. So they planned for this from day one. Canterbury Cathedral takes this concept even further. The nave walls lean outward by up to 45 centimeters. A modern building inspector would have a heart attack, condemn the place, and probably need therapy afterward. But those walls have remained stable for 900 years. And that is the genius part. Medieval engineers understood that buildings are not static objects. They breathe, move, settle in different ways depending on soil conditions, climate, even which side gets more sun. So, instead of fighting the movement, they designed to accommodate it. Modern codes require perfectly plumb walls, zero tolerance for deviations. The Great Fire of London in 1666 destroyed more than 13,000 houses in 4 days. One would expect that the authorities would have studied which buildings survived and why. They did not study them. They simply banned all wooden structures and considered the problem solved. What they missed was crucial. Wattle and daub walls, essentially interwoven sticks covered with a mixture of clay, straw, and animal dung, had been protecting buildings for centuries. The mud coating does not properly burn. It chars. And that charred layer insulates the wood underneath, buying precious minutes during a fire. Sometimes enough minutes to save everything. But there is another trick these walls perform that no one appreciated until recently. They breathe. Moisture passes directly through them, evaporating naturally on both sides. Modern insulated walls trap moisture inside them. Then you get mold. Then you get sick. Then you spend thousands removing everything and starting over. Current fire codes require gypsum boards in most constructions. They perform well in paper tests, but create moisture problems that the medieval methods simply avoided. We traded walls that breathe for respiratory problems. English medieval builders had sheep everywhere. The entire economy ran on wool. So naturally, they started putting wool under their foundations. It sounds crazy at first glance, but raw sheep's wool packed under foundation stones created a perfect layer of drainage and cushioning. Lanolin naturally repels water. The fibers compress evenly under massive weight, and those trapped air pockets insulate against frost heave in winter. Westminster Abbey supposedly rests on layers of wool placed there in 1245, still working perfectly. Modern foundations use concrete and gravel. It seems logical, except that these materials transfer frost damage more readily than wool. When the ground freezes and expands, concrete cracks, gravel shifts, wool simply compresses a little and goes back to normal. Current building codes require concrete and gravel foundations, no exceptions. Those old masons deliberately left their walls looking rough and unfinished, not because they got lazy on a Friday afternoon, but because they were smarter than they get credit for. Smooth stone looks beautiful. Everyone wants that polished finish, but water absolutely loves smooth surfaces. It clings to them, accumulates in microscopic cavities, and slowly erodes the material. A rough surface causes water to hit it and basically explode into tiny droplets that are blown away by the wind. The irregular texture also creates turbulent airflow across the wall, which simply means the walls dry faster after a storm. Victorian restorers looked at medieval cathedrals and thought they would do everyone a favor. They smoothed out all that rough, ugly stone, made everything nice and polished. Within decades, they accelerated the erosion that the original builders had prevented for 400 years. Chartres Cathedral still shows the damage. Centuries of natural weathering caused little harm. A few years of Victorian improvements caused disaster. Modern construction standards require smooth finished surfaces. We literally made illegal the technique that kept these buildings standing. Medieval great halls had a serious problem. They had a problem with people dying from smoke inhalation, so they built chimneys wide enough for a grown man to climb inside. It seems excessive at first glance. It wasn't. These massive flues could be inspected, cleaned, and repaired from the inside. No need for scaffolding. No tearing out the wall. Medieval builders didn't just make one big tube. They stacked multiple flues inside a single chimney stack. And these separate channels created convection currents that basically sucked the smoke out of the building. Think of it as a vacuum cleaner for fireplace exhaust. Compare that to modern chimneys. They are narrow. They meet the minimum code requirements and accumulate creosote like nobody's business. that black, sticky substance that causes chimney fires. Medieval designs avoided this entirely because the airflow never allowed residue to build up. There is a chimney at Conway Castle in Wales that still works perfectly. 700 years old, zero mechanical assistance, zero modifications. Meanwhile, modern chimneys need annual cleaning or they will set your house on fire. Modern construction dries wood in kilns until every drop of moisture disappears. It seems smart, except that medieval carpenters did exactly the opposite, and their buildings are still standing. They built with green wood, freshly cut, still wet, essentially still alive. Why did this work? Green wood shrinks as it dries, about 10%, sometimes more. Medieval carpenters knew this. They counted on it. They cut the joints slightly loose, assembled the entire structure, and then waited. As the wood dried over months, those joints tightened like a vice. No nails needed. The building essentially locked itself together. The massive curved beams of Westminster Hall were cut green and bent into shape while still flexible. 600 years later, they haven't moved. Modern kiln-dried wood does the reverse. It absorbs moisture from damp air, swells, then shrinks again each season, forever. These expansion cycles gradually loosen every connection. Building codes now require kiln-dried wood for everything structural. We traded a system that tightens itself for one that loosens itself. Medieval roofers did not fight the moss growing on their thatched roofs. They encouraged it on purpose, like putting out a welcome mat for that green, fuzzy thing that everyone today removes with pressure washers. Why would anyone want moss on their roof? Because it worked like a natural sponge sitting on top of the house. When rain fell, the moss absorbed it slowly instead of letting the water run off and find every little gap in the thatch below. No sudden leaks, no drips. But that isn't even the clever part. The moss layer added insulation value, free insulation that grew itself, and the bugs are the brilliant part. That moss ecosystem attracted insects that ate wood-boring beetles, built-in pest control that worked 24 hours a day without anyone lifting a finger. A properly maintained thatched roof with its moss layer lasts 50 to 60 years. Modern asphalt shingles last 20 to 30 years with luck. Fire codes and insurance companies effectively killed thatch in urban areas in the late 1800s. Every spiral staircase in a medieval castle turns clockwise as you go up. It seems random, it wasn't. This gave right-handed defenders positioned above a huge advantage. Their sword arm had full range of motion. Meanwhile, attackers coming up had their right arms smashed against the central pillar with every swing. But the ingenuity goes further. Those unequal step heights were not sloppy work. They were trip steps. Defenders memorized which steps were high, which were low, where to place their feet in total darkness. Attackers, stumbling into unknown territory, would fall at the worst possible moment. The narrow central pillar created another problem for invaders. Only one attacker could engage at a time. The guy behind him was useless, just standing there watching his comrade get defeated. Some Scottish families built their stairs counterclockwise. Why? The Kerr clan was famously left-handed. Generations of lefties, so their castles gave the advantage to left-handed defenders. Your family's dominant hand literally shaped your architecture. Modern building codes require uniform step heights and minimum stair widths. Safety regulations that make sense for a shopping mall absolutely destroy 700 years of defensive engineering. Cruc structures completely abandoned the rulebook. Here is what they did. Find a massive oak tree with a natural curve, split it directly down the middle. Now you have two identical curved timbers that match perfectly like bookends. Raise them up, lean them against each other at the top, and presto, you have a frame that carries the entire weight of the roof directly to the ground. The walls are decorative. Seriously, you could knock them down tomorrow, and the building wouldn't even notice. That natural curve in the tree is not a problem to be worked around. It is the whole point. The wood grain follows the shape of the trunk as it grows. When you use curved wood, the grain flows along the curve instead of cutting through it. This makes it dramatically stronger. Cruc buildings from the 1200s are still standing. The frame does everything while the walls just keep the weather out. Modern codes killed this completely. Walls must be load-bearing now, no exceptions. Medieval floors were not really fixed to anything. It sounds like a recipe for disaster, right? But those clay tiles floating over deep layers of sand have outlasted practically every modern floor installation method. The trick was simple. Instead of laying tiles directly onto a concrete base with mortar, medieval artisans poured several inches of fine sand and placed the tiles loose on top. Each tile could shift independently. If the building settled unevenly, which all buildings do, the floor simply adjusted itself. No cracks, no popping tiles, no expensive repairs. Winchester Cathedral still has 13th century floor tiles that look fantastic. 700 years old. Current installation standards do not allow floating tile systems. Everything must be rigidly bonded. Castle walls were not thick just because medieval people liked exercise. Those 2 to 4 meters of solid stone served as the world's first passive climate control system. Here is how it works. Massive stone absorbs heat during the day, stores it like a giant battery, then releases it slowly at night. In summer, the process reverses. The stone stays cool while the sun bakes everything outside. Bodiam Castle maintains internal temperatures between 13 and 18 degrees Celsius all year round. No furnace, no air conditioning, just really thick walls. Energy studies show that massive stone buildings use 40% less heating energy than modern code-compliant structures. We literally regulated ourselves into worse performance. Medieval masons were sneaky geniuses. They built secret arches above every door and window opening, completely hidden from view. The stone lintel you see from the outside is pure decoration. The real structural hero was an arch buried deep in the masonry, doing all the heavy lifting where no one could see. X-rays of old churches have revealed breathtaking complexity. Some walls contain 3 or 4 systems of overlapping arches, each supporting different loads at different heights. Engineers scan these buildings, expecting simple construction, and find intricate networks that would make a modern architect jealous. We abandoned this technique because steel lintels cost less, that's it. Cheaper won the argument. Medieval blacksmiths discovered something about doors that we forgot, and then spent centuries reinventing with springs, hydraulics, and electronic closers. The trick? Mounting the hinges slightly off-center. That's it. That's the whole genius. When you position the hinge pins at a precise angle, gravity does all the work. The door closes automatically. No springs wearing out, no hydraulic fluid leaking, no batteries dying at the worst possible moment. Castle doors using this method weighed 200 kilos or more. Enormous oak slabs reinforced with iron, yet they swung smoothly and closed themselves every time. Zero maintenance required, 0 parts to replace. Master masons built some stone vaults in a cantilever, placing each ring of stones inward, 1 course at a time. No wooden scaffolding underneath, no temporary supports, just stone piled on stone. Each layer stable before the next one went up. How? Every single stone was cut so precisely that it locked into its neighbors through pure geometry. The weight of each new course actually stabilized the one below it. King's College Chapel in Cambridge has fan vaults so complex that modern engineers have studied them for decades. Their conclusion: we cannot replicate them economically today. Not that we don't want to. We can't. Some medieval vaults contain 0 mortar. None. They are held together entirely by stone geometry and gravity, 800 years of holding themselves up through math alone. 20 forbidden techniques, 20 solutions that worked for centuries. And the true genius is that medieval builders figured all this out without calculators, computers, or engineering degrees. Just observation, patience, and buildings that refuse to fall down. The journey through these forgotten techniques leaves us with a disturbing reflection. In our rush for efficiency and economy, we abandoned knowledge that took generations to accumulate. Walls that heal themselves, floors that breathe, structures that tighten over time. All these wonders of medieval engineering were replaced by faster and cheaper alternatives that often do not work as well. Next time you pass an 800-year-old cathedral or a barn that has survived centuries of storms, remember that those stones and timbers carry secrets that we are still trying to understand. And perhaps, just perhaps, true progress is not always about doing things faster, but about doing things that last. If this journey through the forgotten secrets of medieval builders has sparked your curiosity, if you found yourself thinking about how much other ancient knowledge might be waiting to be rediscovered, then you are in the right place. Subscribe to the channel to continue exploring fascinating stories like this one. Leave your like if these forgotten techniques surprised you as much as they surprised us, and share in the comments which discovery most caught your attention. After all, just as medieval masters passed their knowledge from generation to generation, we too can keep the flame of curiosity alive, one story at a time.